Hi all. In this video, we'll be discussing the problems on force system in space. That means when we cannot find a single plane in which all the forces lie. We'll discuss the first problem. Here the figure is given. Determine the forces in the elements AB, AC and AO. In the figure you can see point A and there are three elements AB, AC and AO. And we need to find out what are the forces in these three elements. And if you closely observe the figure, you can see one more force, that is 10 kilonewton acting at A. So in all the problems in force system in space, the first step is to determine the coordinates of all the given points. So here we need to find out the coordinates of A, B and C. Obviously O will be the origin, so the coordinates will be 0, 0, 0. So the coordinates of O, the origin, are 0, 0, 0. Then the coordinates of A are 7, 0, 0. See how you write this coordinates. We know that the first term is the x coordinate, then the y coordinate and then the z coordinate. Now how to find out the coordinates of each point? X coordinate of A is the distance in the direction of x from O to reach point A. In this case, you can see that from the origin, you have to move a distance of 7 to reach A in x direction. So, the x coordinate of A is 7. Similarly, there is no distance marked parallel to x or in the direction of x corresponding to A. And there is no distance marked for A parallel to y or in the direction of y. So the x coordinate, so the y coordinate and z coordinate of A are 0. This is how you identify the coordinates of each point. Now we'll see what are the coordinates of point B. For point B, this is our B. You can see that there is no distance marked in the direction of x. This is our x-axis. So in the direction of x-axis or parallel to x-axis, there is no distance marked corresponding to O. Therefore, the x-coordinate of B is 0. Now, is there any distance marked parallel to y-axis from the origin corresponding to B? Yes, from the origin corresponding to B, B is at this level. So, till this point, from O, the distance in y-axis is 4. So, the y-coordinate of B will be 4. Now, what is the z-coordinate of B? From the level of origin, we have to move 2 distance or 2 units in z direction in order to reach B. So, the z component or z coordinate of B will be 2. That's how you got the coordinates of B, 0, 4, 2. Now, we'll see what are the coordinates of C. For C, in x direction, there is no distance marked corresponding to C from O. So, x coordinate is 0. Now, for y coordinate, this is the direction of y. And in order to reach the level of C or at C, from the origin you have to move in this direction for a distance of 5. But it is given that this is the positive direction of y. It is denoted by the arrowhead or simply the y letter will be written on the positive side. So this is the positive direction of y, but we have to move in the opposite direction to reach the point C. So it will be -5 for y coordinate. And for z coordinate, from the level of origin, we have to move upwards, that is in the positive direction of z for a distance of 7. So z coordinate is 7. Okay. So we have to look at the direction of the arrowhead, or we have to check where the letter is written, and that have to be taken as the positive direction. Instead of y over here, if the y is written over here, then this will be the positive direction. So you have to identify which is the positive direction and take the readings or markings accordingly. Okay, so this is how you identify the coordinates of each point. Now, we have to write all the forces in vector form. In order to do that, we need to identify the directions of the forces. So here we have four forces: force in AB, force in AO, and force in AC, and then the 10 kilonewton force. So these forces, if you draw the forces acting at A, it will be like this. Here we can take these that forces in these three elements as tension forces. So we can mark away from point A. So this is the direction of TAB, this is the direction of TAO, and this is the direction of TAC. And obviously 10 kilonewton is acting downward like this. So this is the force diagram. Now we are going to write the force vectors by looking at these two diagrams and the coordinates. Yeah, here I have the force diagram, the coordinates, and the question figure. Now we'll take AB first. So first we have to write the unit vector. Unit vector in the direction of AB is given by this formula. Here we have discussed this formula in the class. Here we have to do coordinate of B minus coordinate of A. So the first term we have coordinate of B, x coordinate is 0, coordinate of A, x coordinate is 7. So 0 minus 7 is the first term. For the second term, it is 4 minus 0. For the third term, it is 2 minus 0. You got how to write the unit vector in the direction of AB. It is acting from A to B. So it is B minus A. So you got the unit vector. And now how to find out how to write the force vector. Force vector is simply the magnitude of that force into the unit vector. So we have taken the magnitude of this force as TAB. This is what we need to find out. So this is the magnitude. So this magnitude into unit vector will give you the force vector. That is what is done over here. Force vector along AB. FAB is given as TAB. TAB is the magnitude of this tensile force into unit vector in that direction, which is already found out over here. So this is one of the forces. Now we'll take the second force, that is TAO. So what is the unit vector in the direction of TAO or AO? It is the coordinate of O minus A. It is from A to O. So it is O minus A. So this is what is written over here. 0 minus 7, 0 minus 0, and 0 minus 0. So this is the unit vector in the direction of AO. Now, what is the force vector in the direction of AO? It is FAO, and the magnitude is taken as TAO. So TAO into this unit vector. Similarly, you can write for AC also. Unit vector in the direction of AC. It is C minus A. And on simplification, you will be getting this value. So this is the unit vector. How to write the force vector? Force vector along AO, FAC is equal to magnitude. TAC is taken as the magnitude into the unit vector. So we have represented this force, and this force in vector form. But we have one more force, that is 10 kilonewton. But look at the direction of 10 kilonewton. It is acting in downward or in this direction, and we know that this is the positive z direction. So it is not in the positive z direction, but it is in the negative z direction. And we know that the unit vector in this z direction is k. So this 10 kilonewton can be written in vector form as minus 10k. 10 is the magnitude, and this minus sign is put because it is acting in the negative direction of z axis. This is the positive direction. Upward is the positive direction of x-axis according to this figure. So it is acting downward. So we have a minus sign. So at A we had 4 forces, and all the 4 forces have been represented as vectors. So these are the vectors, force vectors 1, 2, 3 and 4. Now this is an equilibrium problem. So we have to apply the equations of equilibrium. But before that, we need to write what is the resultant vector. Then only we can write the equation. We can apply the equations of equilibrium in force system, in space force system. So we'll write what is the resultant vector. Just add these four forces, add the I terms, j terms and k terms separately and write as a vector. So this is the vector obtained. So I have rewritten the resultant force. Now whatever comes with I, see here there are some mistakes in this representation. Is actually TAB minus 1 into TAO. It was correct in the previous slide. So if you want, you can refer the previous slide. So here, see this minus 0.6, it is not the suffix. It is minus 0.63 TAC. Okay. If you have any doubt, you can refer the resultant force vector given in the previous slide. Okay. So whatever term comes with I is known as the Rx value, that is the X component of resultant. Whatever term comes with J is Ry, and whatever term comes with K is your Rz. And now the equations of equilibrium are Rx is equal to 0, Ry is equal to 0 and Rz is equal to 0. So we will be equating these three terms to 0. So first term, the terms along with I is equated to 0, the terms with J is equated to 0, and the terms with K is also equated to 0. Here the representations are correct. It's only wrong. It is only a little different in this equation. So you can refer this. So now we have three equations and three unknowns. We can solve this and find out the value of the forces in AB, AO and AC. And on solving, you'll be getting these values. Okay, so this is how you do this type of problem. The steps that we follow are, initially we need to write the coordinates. Then we have to consider the force diagram and write all the forces in vectors, and then find out the resultant force just by adding the J terms, K terms and I terms separately, and then apply the equations of equilibrium. Equate each term to 0 and finally solve the equations obtained for getting the unknowns. I think we'll discuss one more problem. So this was a university question. Here figure is given. We have a 200 kg cylinder. It is hung by means of two cables. Only two cables are there. A horizontal force perpendicular to the wall. Here we have a wall and P is perpendicular to the wall. And it holds the cylinder as shown in the figure. We have to determine the magnitude of this horizontal force P and the tension in cables AB and AC. So the question is given. This is x-axis, this is z-axis and this is y-axis. So what is the first step? We need to find out the coordinates of the points involved. Here we have point A, point C and point B. So first we'll write the coordinates. Coordinates of A are 1.2, 2 and 0. Here first coordinate is the distance marked in the direction of x-axis. This is the direction of x-axis. So see here you can see that small distance 1.2 is marked in the direction of x-axis or parallel to x-axis corresponding to point A. So s coordinate of A is 1.2. And in order to reach the level of A from the origin in y direction, a distance of 2 is marked. Here you can see that this distance is marked parallel to y-axis corresponding to point A. So the y component of A is 2. And parallel to z-axis there is no distance, so z coordinate is 0. Now we'll discuss the coordinates of point B. For B there is no distance marked in x direction, so it is 0. In y direction you have a distance of 12, so plus 12, and in z direction you have 8 meters, so z component is 8, z coordinate is 8. Similarly for C also there is no distance marked parallel to x-axis, but there is 12 meters marked parallel to y-axis from the level of origin to reach the level of point C. So the y coordinate of C is 12, and from the level of origin, this is the level of origin. From the level of origin, you have to move a distance of 10 meters in the opposite direction of positive z. This is positive z. If you move in this direction, it is plus z, and from the origin, if you move in the opposite direction, it is negative z. So here we have to move in the opposite direction. So it is minus 10. So these are the coordinates of the points. Now we'll consider the force diagram. Here you have how many forces acting at A? You have tension in AC, you have tension in AB, you have horizontal force P, and the weight of 200 kg is acting downward. This 200 kg you have to understand from the unit that this is not weight, it is the mass. So you have to convert the mass into weight. For that you can just multiply with G value 9.81. You will be getting the value in Newton, and this is the weight that is acting at point A. So this is the force diagram. Now we'll represent all the four forces in vector form. These are the coordinates, and we'll take TAB first. So it is from A to B. So the coordinates will be, the terms will be B minus A. Coordinates of B minus coordinates of A. That is how you write the unit vector. You have the unit vector, and the magnitude of the force is taken as TAB. So TAB into this unit vector will give you the force vector. Force vector is equal to TAB into this unit vector. Now we'll take the force TAC. So in the direction of AC, the unit vector is obtained by this equation, and we have to do C minus A. Coordinates of C minus coordinates of A. And this is the unit vector. Again, for force vector, we have to multiply this unit vector with TAC. TAC is the magnitude. And so we have the force vectors corresponding to TAB and TAC. Now, you have a force in the downward direction. Upward direction is Y, and this 1962 Newton is acting downward. So, what will be the force? It will be minus 1962 J, because unit vector in the direction of Y is J. So you have to write this with J term, and we have to put minus because it is acting in the opposite direction of Y. In the figure, upward direction is taken as, it is given as the positive direction. So since the weight is acting always downwards, it should be taken as negative. Now we have one more force, that is P. The magnitude is taken as P itself, but it is acting in which direction? It is acting in the direction of X. So it have to be taken as I component. So force P is written in vector form as P into I. Okay. So here we have represented all the four forces acting at A in vector form, and the resultant is obtained by adding all the I terms, J terms and K terms separately. So these are the four forces, and we have added all the terms separately. This is the resultant force. Now what is the next step? We have to find out the unknowns. So we will be applying equations of equilibrium, and will be equating each term with 0. So this is the resultant vector, and we are applying equations of equilibrium. Each term is equated to 0. Rx is equal to 0. That means the terms with along with I is equated to 0. Ry is equal to 0. That means the terms along with J is equated to 0. And Rz is equal to 0. That means the terms along with K is equated to 0. Now on solving these three equations using calculator, we'll be getting the magnitudes of the three forces. Okay, so this is how you normally do equilibrium problems in force system in space. Okay, thank you.